Assalamu alaikum. So in this video I will solve Schrodinger equation in 2D, and in this video I will take an example of square whale. That means I have a square here. Let's say I have a square here. The length of the square across the x direction is Lx, and at the y direction I have, let's say, Ly, and inside this square the potential energy is 0, but outside this square the potential energy is infinity. Let's say here the potential energy is infinity, and that means no particle can stay here. To stay here a particle needs infinite energy, right? But as it is not possible, that means no particle can stay here. The particle, if you will get a particle's wave function inside the square whale. Okay, so let's do this thing, and at the end of the video we first we will solve this equation numerically, theoretically, and then at the end of the video we will make a code to find the psi x versus xy graph, and then the probability density versus xy graph, and we will see for different quantum numbers. Okay, so let's start. So I have a differential equation, Schrodinger equation. Let's say delta minus h bar divided by 2m delta square psi plus u psi is equal to e psi. And if I take inside this square whale, inside potential energy is 0, right? Here the potential energy is 0, so minus h bar square divided by 2m delta square psi is equal to e psi. Okay, let me take this h square by 2m at the right hand side. The delta square psi is equal to minus 2m divided by h bar square e psi. Okay, so as now psi is a function of x and y, then we can write this psi into psi x and into psi y, where psi x is the only function of x and psi y is the only function of y, and this technique is called the separation of variables. That means a function which is dependent on two variables, and I have separated this like this. Okay, so now let's write this thing, this psi in this equation. Then I will get let's write delta square into delta square divided by delta x square plus delta square divided by delta y square, psi x psi y. Okay, let me this thing like this. Okay, let me write delta square is equal to delta square by delta x square, delta square divided by delta y square, and we have a psi here, so write the psi here and here, and then minus 2m divided by h bar square e into psi. Okay, so now I have to differentiate psi with x, but as only psi x is the function of x, so we can differentiate only psi x, and psi y it will be written here. And again, as psi is as only psi y is function of y, so we can differentiate only psi y here, but we can differentiate psi x with y, so I have to write psi x here. Then minus 2m divided by h bar square e psi is equal to psi x, then psi y. And now I have to divide this equation. I have to divide this equation by psi x psi y. So I will divide this equation by psi x psi y, and you will see what happens. If I divide the first term, I will get 1 by psi x delta square divided by delta x square psi x, and then I will get here 1 by psi y delta square divided by delta y square psi y is equal to minus 2m divided by h bar square e. Okay, so I have two terms here, and at the right hand side I have a constant. And if you observe carefully, that at the first term I have only x and the function of x. At the second term I have only y and the function of y, right? That means this term is independent of this term, and this term is also independent of this term. How? Let me show you an example. Let's say the first term initially is 3 and the second term is initially 4. So if I differentiate this thing, I will get 7. And then let's say I have changed this 3. Let's say I have took this first term at some another x, so I will get let's say the first term has been changed somehow, then I will get here, let's say 5. And if I change the first term, I also have to change the second term to make the right hand side constant. As the right hand side is constant, then the 7 will become constant, right? But changing the first term will also change the second term. The answer is no. Listen to me carefully. Changing first term can also change second term. No, the answer is no, because if you observe this equation carefully, that if you change this term will be unaffected. If you change second term, the first term will be unaffected. Why? Because the first term is only the function of x, and at the second term you have only y. So if you change this term will be unaffected, right? That means if you change first term, let's say if you change 3 to 5, the second term must be unaffected. But if you do so, the summation is changed. That means the right hand side is not constant. But no, in our equation the right hand side is constant. That means we cannot change the first term. That means first term is also constant, the second term is also constant, and constant plus constant is equal to another constant. So the first term is constant, right? That means the first term 1 by psi x square delta square psi x delta x square is equal to one constant, let's say psi x square, and another constant 1 by psi y delta square divided by delta y square psi y is another constant, let's say minus this. Okay, so now I have to solve this first equation. Let's solve this first equation here. So let's rewrite this equation like this. Okay, so now this equation is only dependent on x position. So let's take this psi, let's solve this equation. So this is x and this is the psi x, which is only the function of x. So if I take only from 0 to Lx, what was Lx? The Lx was the length of that square across this x direction. So outside this, from outside of 0 to Lx, outside of this region, the potential energy is infinity, and here also the potential energy is infinity, right? And I have mentioned you previously that one particle needs infinite energy to stay here, but it's not possible. That means the psi x, the wave function here is 0, and the psi x here is 0. That means I will get a psi x in this region. Okay. So now let's solve this equation. So if you know how to solve a differential equation, you know that we have to write delta square. Instead of this delta square divided by delta x square, I have to write here lambda square, then minus kx psi x. And from this equation is clear that lambda square is equal to minus kx square. Oh, x is subscript, okay, k, and the subscript is x. And I can write this minus 1 is equal to the square of that imaginary number, and lambda is equal to plus jkx minus jkx. Okay, so let me write psi x is equal to c1 e to the power jkx, c2 e to the power minus jkx. Okay, so let me write e to the power jkx into cos kx into x. Oh, I didn't write here x and x. Okay, so cos kx plus j sin kx into x, and then again c2 then again c2 into cos kx into x minus j sin kx into x. Okay, so if I took the coefficient of cos, and to do so I have to take summation of c1 and c2, and let's say that the c1 plus c2 is another constant a, and again if I take the coefficient of k sine, that means c1 into j plus c2 into minus j is equal to another constant, let's say v, and a and b might be what, real or imaginary. We'll see that a and b is real or imaginary or zero. We'll see that. Okay, so what we have get previously, that from 0 to lx, here psi x is equal, oh wait, one minute, I haven't told you one thing, that I find that here psi x is equal to 0, right? But as psi x is continuous, that means at this point psi x is also is equal to 0. Similarly, at this region psi x is equal to 0, but as psi x is continuous, that means I will not get an abrupt change here. That means it's not possible that in this region psi x is 0 and in this region psi x is equal to 2. No, it's not possible. Oh, 1 minute please. Okay, so what I have told you, wait a minute please, I don't know what's happening here. What's happening to my code here? Okay, so what I have told now, that it's not possible that here psi x is 0 and suddenly it becomes psi x is equal to 2. No, it's not possible. So we can say that so you can tell that at this point psi x is equal to 0. Okay, so when x is equal to 0, psi x is also is equal to 0, and that means cos 0 is equal to 1 and sine 0 is equal to 0, right? Okay, so I get here, from here 0 is equal to a into 1 plus b into 0, so I have got here a is equal to 0. That means this term will be equal to 0, and I will get psi x is equal to b sine kx into x. Okay, and now let's take this point when x is equal to lx, this is equal to 0 again. See, at x is equal to lx, psi x is equal to 0, and b sine kx into lx, so this term is equal to 0. And now if you take b is also is equal to 0, then what is the meaning of psi x? Psi x is all the points 0, right? As a is equal to 0, b is equal to 0, that means psi x is everywhere 0. But no, a is equal to 0. Okay, let's take this into consider, that a is equal to 0, but simultaneously we can take b is equal to 0, so b is not is equal to 0. Okay, so we have two things here, one is b and another is sine. So b is not is equal to 0. Okay, so definitely sine kx lx is equal to 0 to make this another term, another side is equal to 0, right? Okay, so sine kx into lx is equal to 0. Why? Because b and a cannot be simultaneously 0. Okay, so when sine function becomes 0, if you take sine n pi nx pi, where nx is equal to 1 2 3 dot dot dot, then you will get sine is equal to 0, and from here I can write kx into lx is equal to nx pi. So kx is equal to nx pi divided by lx. Okay, So psi x is equal to b sine nx pi divided by lx into x. Similarly, I have another psi y, right? So I can write psi y is equal to, let's say here another constant b prime sine ny pi by ly y. Similarly, I can write this thing also. Okay. So now how can I find the coefficients b and b prime? I don't know what is b and b prime, and to find that thing I have to take psi square, where I have to take this, I have to take an integration, where in this square. So in this square I have to take an integration. First I will take an integration from 0 to lx, and then I will integrate by y from 0 to ly, and if I integrate this thing I will get 1, right? Okay, so psi square dx into dy. Okay, let's see. Let's first write the psi square. So psi square is equal to, first I have to write here sine square, and then I have to write here sine square ny pi by ly. Here I have x, y, and if I multiply b and b prime, let's say I will get another constant, another coefficient, and that is c. Okay, so now as this term is only function of x, so I will integrate this with x, and again as this term is only function of y, I will integrate this term with y, and this will be equal to 0. So this is a basic integration, this is a basic integration. Okay, so if you integrate this thing, you will definitely get this term is equal to, oh wait, b square and b prime square will be equal to c square. Okay, okay, so you will definitely get here, sorry, c square, you will get here 2 by lx, and here you will get 2 by ly. Okay, let's check one thing. Okay, let's check only one thing. Will I get this term is equal to 2 by lx or not? And similarly we can tell that this term is also is equal to 2 by ly. Okay, let's see the first thing here. Let's see n square sin square nx pi by lx into x 0 to lx dx is equal to what? Let's say it's equal to 2 by lx or not. So to do this I need to write here 1 by half and again multiply by 2. So what is 2 into sin square some angle? It is simply is equal to 1 minus cos 2 twice into that angle x. Okay, so now if I differentiate it with x, I will get, if I differentiate 1 I will get simply x, and if I differentiate cos I will get sine. And at the denominator I will have to write nx pi divided by lx, and this will be equal from, oh I don't need to write that here, instead I can write this here. Okay, and now let's take lx here, so I will get lx, and again take 0 here, then I will get 0. Okay, now the second term, 2 into n pi nx, here is nx not pi, nx pi divided by lx. Oh, and here we have not 2 here, only this thing. Okay, oh sorry, we have 2 here, sorry, yes we have 2 here. Okay, but this denominator doesn't matter. Why? You will see that if I put lx here I will get sine 2 nx pi divided by lx into lx, then if I take 0 here I will get 0. And now please look carefully, this lx and lx cancels out, then I will have sine nx 2 pi. So what is sine 2 nx pi? and you will see that it is always equal to 0. Why? Let's take nx is equal to 1, then you will get 0. Let's take nx is equal to 2, that means 4 pi so also is equal to 0. That means this term is always equal to 0, so I will get half into Lx. Oh, so I have made a mistake, right? So it is Lx by 2. So it is Lx by 2, not 2 by Lx. So it is Lx by 2, and similarly it is Ly by 2. So from here I will get the value of C, root over 4 divided by Lx Ly. Okay, so I have obtained C, and now I need to find psi, which is equal to psi x into psi y. Can you remember from separation of variable I get this? So psi x is equal to b sine square kx pi by Lx into x, then b prime. Why sine square? It is only sine. B prime sine ky pi by Ly into y, and then what we have to do, multiplication of b and b prime simply becomes c. And what is c? C is equal to root over 4 by Lx Ly. So c is root over 4 divided by Lx Ly. And we can also write this thing like this, that 2 by Lx sine kx pi by Lx, and then root over 2 by Ly sine ky pi divided by Ly. So this is psi x and this is psi y. We can write that psi like this. Why I write this? Because I have code, I have write a MATLAB code here. Where is my MATLAB code? Okay, so here is my MATLAB code. So what I did here, so let's say Lx is equal to 2 millimeter, and I have take that nx and ny, which are the quantum numbers. Let's say nx is first 1 and then ny is 1 for the first state, right? And then I have, these are sx, that means psi x and psi y, and then I multiply this thing. Oh, this is, I don't need this actually. So this is psi, which is multiply of this, and then I get the probability density function, that means psi square, and then I plot x y psi, and then again I plot x y and the probability function, right? And if I run this code, let's see what happens. Okay, so I get two things here. Okay, so at the right hand side, this is okay, so this is our psi, and this is psi square. Okay, and now if I take 2, let's see what happens. 2 here and 2 here, and if I run this code again, okay, this is, then I get like this. So let me tell you why I get this thing. Okay, so let's write this here. Okay, so for nx is equal to 1, I will get psi x versus x graph. Here always psi x is equal to 0, and when Lx, psi x is always is equal to 0, right? At this point and this point, psi x is always equal to 0. And so when nx is equal to 1, I will get a psi x like this, and when nx is equal to 2, I will get psi x like this, and when nx is equal to 3, I will get psi x like this. Okay, so let's see, when nx is equal to 2, I get, okay, so see, if I see from the x-axis, okay, so if I see from the x-axis, you'll see that one is at the highest magnitude and another is at the lowest magnitude. Okay, this is okay. And similarly, this thing will happen for y. This same thing will happen for y. If ny is equal to 1, I will get psi y is looks like this, and if ny is equal to 2, I will get like this. Okay, so let's do this thing again. For nx is equal to 5 and ny is equal to, let's say, 3, and let's see. Okay, so this is psi x. So if I see from x, you will see here what was the value nx was, nx was 5, right? And that means as nx was 5, I should get one half circle, 2 half circle, 3, 4, 5 half circles, right? Let's see, I have 5 half circles or not. So I have 5 half circles, 1, then 2, 3, 4, 5. Again, if I see from here, I'll get 1, 2, 3, 4, 5. And what was ny? Ny is equal to 3. That means I should get, as ny is equal to 3, then I should get 3 half circle. Okay, so I obtain 3 half circle, and let's see if I see from y. Okay, so if I see from y, and you see that I have 3 half circles here, 1, then 2, then 3. And if I take another region, 1, 2, and 3. Okay, let's now move on to psi x square, psi square. So if I try to plot psi square, then this term will squared, but this negative term will becomes positive. Then again looks like this, and like that. Means I will have 5 positive terms if I look from the x-axis. And again, psi square will, that psi y, and this is psi x. So psi y square will looks like this, 3 lobes, 3 lobes here. So let's see. Okay, so we should get 5 lobes at x-axis and 3 lobes at y-axis, and let's see. It is the psi x square graph. You see no negative lobes here, all is positive. So x-axis from if you see from x-axis, 1, 2, 3, 4, 5. Here also 1, 2, 3, 4, 5. And if you see from y-axis, you will get 1, 2, 3. Okay, so this is the result from Schrodinger equation. And if one thing remains, that we have an energy equation here. If you remember this, if you can remember this thing, that we took this first term is equal to minus kx square, right? And the second term is minus ky square. So minus kx square, let's write the equation. This is minus kx square and this is minus ky square. which is equal to minus 2m divided by h bar square into E, right? Let's write this thing. Okay, let me copy this thing and let me paste that here. How long is this video? Oh, 30 minutes. A long video, right? Okay, no problem. Okay, let me write this equation by my pen. Uh-oh, again something going wrong. What is the problem? Okay, okay, let me pause the video and see what's the problem. Okay, so minus kx square minus ky square is equal to minus 2me divided by h bar square. Let me multiply by plus 1, then I will get this like this. And if you remember that we have kx is equal to nx pi by lx, so right here nx square pi square divided by lx square, again ny square pi square divided by ly square, to m e divided by h bar square. So I have E is equal to h bar square divided by 2m, then nx square divided by lx square. Let's take pi common here, so ny square then ly square. And if I have a square here, I mean if I don't have a rectangle, let's say square, that means lx is also equal to l and ly is equal to l. So let's see what happens. Then h bar square divided by 2m, then let's take l square common here, write this pi square here, then I will get nx square and y square. I don't know what is going with my notepad. Okay, let me pause this equation again. Okay, this is the end. Okay, this is the end of the video. Now I have to put this, now I need to put this thing in my code and I will get the energy for each quantum state. Okay, so this video is we will see you at the next video. Bye.